Okay, guys, so we're going to continue with evaluating logs in this section. We're going to do some of the more challenging ones. So one of the things that I wanted to do is just kind of refresh your memory on some of the concepts that we covered earlier in our course. So when we had negative exponents like 3 to the negative 2, what we do with that negative exponent is we rewrite it as a positive exponent and we relocate it into the denominator. And then we put a 1 up top. We're going to just erase those random marks. And so now we have 1 over 3 squared, which is equal to 1 over 9. All right, same idea with this next one. We've got 4 to the negative 2, so that's going to be 1 over 4 to the positive 2 when we rewrite it. And then 1 over 4 squared is going to be 1 over 16. All right, for the next one, we've got 2 to the negative 5, so we're going to rewrite that as a positive exponent down in the denominator. And then 2 to the 5th is 32, so we've got 1 over 32. And then for 5 to the negative 3rd, we're going to rewrite that as 1 over 5 to the positive 3rd. And that's going to equal 1 over 5 to the 3rd is 125. All right, so if you've got a negative exponent, it changes it into a fraction. That was just kind of a little recap for you. All right, so also another thing that we did with rewriting is we took our radicals or our roots and we rewrote them into rational exponents. So for the next one, we've got the cube root of 8. So I could also write that as 8 raised to the power over root. So it's going to be 1 over 3. But we know the cube root of 8 is 2. So the cube root of 8 is 2. Same with 8 to the 1/3. That's going to be 2. All right, 25. We're going to rewrite that first as 25 raised to the power, which is 1 over root. This is the square root. So technically there's a 2 in that little nook. So 1 over 2. And then that's 25 to the 1/2, which is the same thing as the square root of 25, which equals 5. All right, for the next one, we're rewriting first as a rational exponent. So it's going to be 27 raised to the power over root. So 1 over 3. And the cube root of 27 is equal to 3. All right, next one, we've got square root of 16. So we want to rewrite that first as 16 to the power over root. So 1 over, and remember when you have the square root, that's like a 2 in the nook, 1/2. And the square root of 16 is equal to 4. All right, so we needed to kind of recap that because what we're going to do next is going to use that knowledge of the negative exponents and the roots where they become rational, which is like a fraction. Okay, so back on the evaluating, we're going to do the same exact thing that we did before, where we set it equal to x, because we're trying to find x, and now we're going to rewrite it in exponential form. So swoop, 7 to the x equals 1 over 49. So x is going to equal, all right, so I know 7 squared will give me 49. So it's going to be something with the 2, but because it becomes a fraction, that's the same thing as 1 over 7 squared. What would have made that 2 go into the denominator? Well, if it were a negative up top. So my unknown, my exponent is negative 2. All right, for the next one, we're going to set it equal to x, and then we're going to swoop 3 to the x equals 1 over 27. So x is going to equal, all right, so 1 over 27. Well, I know 27 is 3 to the 3rd. But what made that 3 to the 3rd go into the denominator? That's if the exponent were a negative 3. So my unknown is negative 3. So when we have those fractions, it equals a fraction, that negative makes it go into the denominator. All right, so likewise, number 3 equals x. We're going to rewrite, swoop, 2 to the x equals 1/8. And I know 2 to the third equals 8, so 1 over 2 to the third, that's the same thing as 1 over 8. And x is going to equal, all right, the thing that makes that 2 to the third go into the denominator is a negative with that 3. So x equals negative 3. All right, so for number 4, we're going to set that equal to x. Swoop, 6 to the x equals 1 over 36. So x is going to equal, all right, I know 6 squared is 36. The thing that would make that squared go into the denominator is if it were a negative 2 originally. So negative 2 is the unknown. All right, so that's what we do for these ones. Okay, on to the next set. All right, so we've got setting that equal to x. We're going to swoop 49 to the x equals 7. All right, so it's not a fraction, so it's not going to be a negative number. But I know, what do we need to do to 49 to get 7? Well, we square root 49. That equals 7. So power over root, that's going to be 49 to the 1/2 is going to equal 7. So x equals 1/2 because power over root, the square root of 49 is 7. All right, so this is a little tricky. I'm going to do a couple of these a little bit slow so that we got this. Equals x. So we're going to swoop. So 125 raised to the x equals 5. All right, so it's not a fraction. 125 to the 1 is 125, so it's smaller than 1. So what root of 125 would equal 5? And that's the cube root of 125 equals 5. So power over root, x is going to equal, what's the power over root? 1 over 3. Cube root of 125 equals 5. All right, next one. We've got equals x. So we're going to swoop 36 to the x equals 6. All right, it's not a fraction, so it's not going to be negative. All right, what type of root of 36? So the square root of 36 is going to equal 6. So x is going to equal, square root means power over root, so 1 over 2. So my exponent should be 1/2. All right, last one. We set that equal to x and we swoop. 27 to the x equals 3. All right, it's not going to be a negative because it's not a fraction. The what root of 27 will equal 3? That's the cube root of 27. So x is going to equal power over root, so that would be rewritten as 1 over 3. There we go. All right, so that is how we tackle those ones where it's a root. Now, the next couple, I'm going to do the same exact thing. We're going to set it equal to x to solve. Uh-oh. But this one, we don't have a base. I don't have a base here. If you don't see a base, like above the base is 49, the base is 7, this one doesn't have a base right here. So we write in 10. Anytime you don't see a base, you write in a 10. So now we do swoop 10, my base is 10, to the x equals 100. 10 raised to what power equals 100? 10 squared. So my exponent is 2. All right, next one. We don't have a base right there, so we got to rewrite that as a base of 10. And then we could do equals x. So then we swoop 10 to the x equals 1 over 100. Oh, it's a fraction. 100 is 10 squared. So that's like saying 1 over 10 squared. So x is going to equal, what does the exponent have to be to make that square go into the denominator? A negative 2. All right, on to the next. I don't see a base for that next one, so I'm going to write in 10. And then I'm going to go ahead and approach this the same exact way. So I set it equal to x, and then I swoop 10 to the x equals 0.1. All right, so I got a little tricky on this one for you. This is 0.1. That's like saying 10 to the x equals 0.1 is 1/10. Oh, now it's a fraction. Now it makes a lot more sense. Okay, so if we have a decimal, just change it into what that decimal fraction would represent. So 0.1 is 1/10. So 1 over 10. All right, so now x is going to equal, well, the 10 went into the bottom. This has an exponent of 1 technically with it. So what does that 1 need to be to make it go into the denominator? A negative 1. All right, and the last one, we've got no base with that, so we put in a 10. Anytime you have no base with the word log, we just write in a 10. So then equals x. Now we're going to swoop 10 to the x equals 1,000. I want to make that look more like a comma instead of decimal. So x is going to equal 10 to what power is going to give me 1,000? 3. And that's it. All right, so now you guys can try the assignment for this.